other classes. For derivative rules, you don't have to come, but if you want to come, we're going to make the foldable. It's going to have all the derivative rules. It's a great way to study. So come on by. Tonight's homework is assignment number 43. Now, when you see it, you might freak out a little bit because it's questions about inverses. It's not questions about calculus. It's about inverses and derivatives of inverse functions. So it's going to look and feel a little bit different. But you guys are going to be okie dokie. One last thing is there have been a lot of folks that recently have been telling me, gosh, I really need to start studying earlier. Studying the night before the test isn't good enough for me. That's good. I've been telling you that since August. You're studying the night before is not good enough. You should be starting now. So I'm going to email you guys later a recommended list of assignments. These are all things that are in the unit guide that I would encourage you to start looking at now. And I'm going to email you the solutions. So that if after you do tonight's homework, you're like, hey, I want to take 25 minutes and I want to work some multiple choice questions. There's 40 multiple choice questions in the back of the unit guide. And you'll have the solutions so you can start working through those. Everybody good? Mm-hmm. All right, so that's the plan. All right, so here's what we're going to do. I did not take attendance. I can't believe I didn't do that. All right, you guys have 5 minutes. I'm on page 27 in the unit guide. You are going to go completely on your own for this. You're not going to get any help from anybody. You've got 5 minutes for parts A and part B. Show me what you can do. I'm going to be a really proud papa. Page 27. some good stuff. This is the level we need to be performing at. Alrighty. Ready? That was, so first of all, that was 5 minutes. Just want to be real. That was 5 minutes. Alright, here comes part A. Okay, part A, g of x equals x squared f of x. Find g prime of 2. Whenever you're going to do a problem like that, you need to do 2 steps. First step is you need to find the derivative with respect to x. And from what I saw, just about everybody had product rule? Was product rule obvious? Okay, x squared, 2x times f of x plus x squared times f prime of x. If you have that, 1 point, give yourself the first point. To find g prime of 2, now you're going to plug in 2 everywhere there's an x. 2 times 2, 4 times f of 2 plus 4 times f prime of 2. Well, where the heck am I going to get f of 2 and f prime of 2 from?
The graph.
We're going to have to look at the graph. F of 2, if this is the graph of f of 2 says look at the y value. F of 2 is negative 4. But what about f prime of 2?
You know it's a relative minimum.
You know that you have a relative minimum. What's f prime at 2? What's the derivative? What's the slope of the tangent line at 2? 0. When you put all of that information together, you're going to get that g prime of 2 is equal to negative 16. Honest hands, how many of you guys have negative 16? Okay, pretty good. I can deal with that. For the folks that didn't get there, you've got until Friday. We're going to figure it out. I'm available today during lunch, Tuesday during lunch. We're going to get this under control. Don't freak out yet. It's too soon to freak out. Blue people. Okay. Let's see. Part B. H of x equals f of x divided by x squared. Determine whether the function h is increasing or decreasing at x equals 4. Increasing or decreasing, if you're going to figure that out, that means you're looking at the derivative. How am I going to find the derivative?
Quotient rule.
Quotient rule. Trust me, in this unit, Sylvia, when in doubt, find the derivative. This whole unit's about the derivative. Quotient rule. Low d high, x squared times f prime of x, minus high d low, f of x times 2x, over low, x squared squared. Okay, that would get you the first point if you found the derivative correctly. How many guys get that first point? Okay, we're in a pretty good place. Now I'm going to find the derivative at 4, just like we did before. Everywhere there's an x, plug in 4. 16 times f prime of 4 minus f of 4 times 8 over 16 squared. Now, your goal is to figure out what's h prime of 4. And I don't know that I saw anybody get past this point. Did anybody get past this point? Yvel did, Gerson did. Gerson, tell me a little bit. What did you do?
I I tried to graph the derivative of f of x.
Okay, we know that this is f of x. So you tried to graph the derivative. Is there anything you know about the derivative that's going to be really helpful here?
Well, there's a root at x equals 2.
There's a root. The derivative will have a root at x equals 2. I agree. But what I need to know is I need to know about f prime of 4. Daisy, what do you know about f prime of 4?
So I looked at the graph and I saw that f prime before was 0, but it was increasing, so I thought...
Hold on. I disagree with what I heard you just say. I don't know if anybody else heard this. What I heard Daisy just say is I looked at the graph and I know that f prime has a root at 4. F has a root. Everybody okay we have a root at 4?
Yeah.
So that means that f of 4 has to be 0. What about f prime of 4?
Oh,
What about f prime? Henry, what do you know about f prime of 4?
never mind.
Oh, it was there. F prime of 4. Look at the graph. Is there anything? Paul, help me out. What?
Prime is above the x-axis.
F prime of 4 is what?
Above the x-axis.
F prime of 4 is going to be above the x-axis. The thing that you know for sure, eval, F prime of 4 is...
Increasing.
Oh, I'm dying again. I'm dying on camera. Kids in Ohio are like, why don't they know? What's F doing at x equals 4?
It's increasing.
It's increasing. Anybody know anything about F prime of 4?
Above the x-axis.
Oh, no.
Greater than 0.
Shh. It's greater than 0. Thank you, Gonzalo. I'm starting to like you more, no matter what Michelle says. F is increasing at 4, so F prime of 4 has to be positive. Now, positive what, Chris? I don't know.
Oh, you don't.
I don't know positive what, but you know what? I don't care either. Here's what I know. 16 times a positive number is
Positive.
positive. Minus 0 times 8?
0.
Positive.
Wait, positive.
Right. This part's 0, this part's positive. Positive divided by 16 squared
Positive.
is positive. So h prime of 4 is positive. Which means that h is increasing at x equals 4. Yep. That's it. Daisy.
So you wouldn't get a point for plugging in 4 into h prime?
Just getting to like this part here, probably not.
Okay.
Probably not. Alright, so here's what I want you guys to do. I want you to decide, do you want to A, work on a problem very similar to what we just did, in which case that's problem number 2. Problem number 2 is a really good one. Or option B, do you want to work with the problem that involves tables? That's problem number 4. You're only going to get the next 10 minutes to work on this. So if you're going to do problem number 2, it's pretty similar to what we just did, Jackie. That'll be good practice. Problem number 4 involves derivative rules, working with tables. Life is good. You get 10 minutes. Where are the folks that are going to work on a problem that's pretty similar to what we just did? You need to like boost your confidence and feel good about yourself. Okay? And where are the folks that are going to work on something different, like those table questions? I see Rebecca. I see Garcon. Okay, let's have the folks doing question number 4 group together over here around Rebecca. Everybody else, question number 2. You got 10 minutes. I'm going to circulate. I'll help out. Hi.
If we want to study tonight, we want to do the problem that we did in class.
Not all of them? Oh, do you mean for this one? Yeah.
Thank you.
You're welcome. For you, Jalissa, anything. Okay, here are the most up-to-date grades. Okay. Oh, Gonzalo, you guys working on question 2 or 2? Okay. Daisy. Jeanette. Chris. Chris, here you go. Sylvia. Okay. That says Henry.
Okay, what does it mean when it's like this positive constant? Like, so hey, it's a positive constant, so k can only be 2, not just 2. Yeah, but like, you know how it's quotient rule, right? is x times the derivative of the top. There's x times the derivative of height. So what's the derivative of the height? K is constant.
Yes, I did. The only thing is that I didn't know them because I wrote a lot on my paper. I did. Do you want to see the other paper?
Just K? Yeah. I mean, the x times K. It's like, you know when you used to do the problem with A?
Do you want to see the other paper?
Yeah, I know, but I don't get it. Next time.
Okay.
No, you got to find the derivative
So
away.
we're supposed to find
That
the
way you just plug in.
derivative with the x part.
Like, you know how it says K is constant? Does that mean that the derivative would be x times just K by itself? It's like you go to
Do you have the grades?
constant.
Yeah. So think about if it was a number, K was 2. How would you find the derivative of 2 over x?
I mean, it was like higher before.
Okay. It's just like regular? Yeah, would it be 1? Because you do regular, you find the derivative of K, just K to the 1, so you drop the 1, subtract the 1.
K is a constant, Henry.
Okay.
So would it be so we know it's flat. So why did this?
Negative K?
Just send me an email as a reminder. You'll be here Friday, right?
Quotient Rule.
Friends over here.
So it'll be x times the derivative of top minus.
Yeah.
I did the quotient rule for Kale.
Oh wait, no, you know what? You were sure take the derivative of Okay. No. The stuff is the entire exponent.
Derivative of constant is 0.
So it's in square root of 1 over square root.
No, because the derivative.
I'm liking some of what I see here, not all of it. First of all, when I'm asking you to find the derivative at e, it's a 2 separate one. You're trying to do both sides at the same time. So this is an f prime of e.
If you leave the baby alone, then you take the.
So the first step is find the derivative. The second step is plug in e. Now, when you found the derivative, how did you do that?
So that, and then just
I did a quotient rule for Trig.
So what's k prime? What do you know about k? Okay, so background to this question.
Wait, no, I'm too late.
this is
Quotient
the
rule but
baby.
positive.
This is no, this
K
is
is a positive constant.
no, because this is That's not over.
No, and like it's like
No,
That's
these
like
two
oh.
squares have a constant difference.
So just out of your
What's the
So
derivative?
it is zero.
this is literally the same thing that happens.
What's the derivative of 4?
You're just saying k to the 1.
0,
Start the 1.
Y.
Minus 1.
bring the power.
The derivative of a constant is 0.
Oh yeah.
Wait, what, the plus? I thought it was a difference.
No, it just means the,
Yeah, I thought it was the other.
There's parts here that I like and parts here that I don't like.
I know you do it next time.
Okay, the fact that you would choose to use quotient rule makes sense to me. You see a fraction, so low d high minus high d low d low. This derivative is wonderful. I have problems back here. What's k prime?
What about 1 over?
K is constant. What k prime is? No, that's not what I just said. The derivative of a constant is 0. So if you're trying to find of that constant, 0. Otherwise, even is k.
to be negative.
Well, okay,
This is what this is
If you're going to take the derivative of 1 over the square root of x times 1
yeah, because you have to find it. Yeah. Is there
But they never give it.
and then you multiply that.
Because I already took all the classes on
So I was thinking about adding
I'm down for sure, but this is
well, okay, so you need to not break the derivative here is okay, I think you still need to find this derivative. Oh, we're trying to see. Okay, so simplifying would make your life better. I'll bring your meat. What?
you have x times.
So first you find it right?
Not enough.
We're not supposed to work at prime.
To add, you have to have the same time. To multiply, you have to have the same time.
So you first do the quotient, and then you put the plus sign, and then say or add or not times all.
Okay, so over here, have Yep. Just adopted Sylvia and you have to pay her way through college. Alright. Now I want to push you all. No matter where you are, whether you're making progress on question number 2 or working on number 4, we're all going to go over to question number 5. Okay? We've got 12 minutes, which is not exactly as much time as I wanted, but I'll take it. I'll take it. So Henry, Abel, Jose, if you could hold on. Karina, can everybody at home see? Excellent. This question is totally fair game.
A particle moves along a line so that at any time t where t is greater than 0, the particle's position is given by this equation over here. What is the velocity of the particle when the acceleration is first equal to 0? Take a moment. Think through that. Have a conversation with the folks around you. What's going through your mind? Henry, you haven't even spoken to Sylvia yet. Sheila, I mean.
It's 6 years.
Alright, let's pull it back together. What's the velocity of the particle when the acceleration is first equal to 0? I want to get some thoughts on this. I see Henry and Karina and Paul, my 3 usual suspects, and I love you all for this. Jose, what are your thoughts?
We have to find the derivative and then the double derivative.
Why?
Because velocity is the first derivative and
Okay, velocity is the first derivative of position and acceleration is the
the second derivative.
second derivative. Is everybody 100% okay with this?
Yes.
Okay, so I would hope that somewhere on your paper you're going to take a moment and you're going to go find the velocity. Go find that velocity. Position is cosine of 2t plus 2t squared plus pi. Alright, derivative cosine of stuff should be negative sine of 2t.
Why is it B? Oh.
We're talking about velocity.
Yeah.
So we're taking derivative cosine of stuff. So negative sine, leave the stuff alone, times 2. Negative sine 2t times 2? Okay. Plus derivative of 2t squared, 4t. I would hope everybody is coming up with this derivative. Yeah? Okay. Great. You just earned a point. Acceleration, you need to take another derivative. So negative sine of 2t times 2, I'm taking the derivative here. Well, gosh, derivative of negative sine
Negative cos.
is negative cosine of 2t times 2 times 2 again. I love that moment. It always happens every year. Where did the second 2 come from? Evel sees it. Gonzalo, you think you see it?
Yeah.
Where?
Oh, you found the derivative of the baby of sine, negative sine of 2t.
When you take the derivative of sine of 2t, it's cosine of 2t times 2. This guy here is from your chain rule.
Oh.
Why is that 2 there? That's the 2 you were multiplying by in the beginning. When you take the derivative of a function times a constant, the constant just comes along with you. Right? Go off on the side for a second. What's the derivative of x squared? Everyone's going to tell me? 2x. Okay, what about the derivative of 5x squared?
10x.
10x. It's because what you do is you ignore the constant and you take the derivative of x squared. You're like what's happening is in your brain you're multiplying them. You're forgetting that really you say take the derivative of x squared and multiply by whatever's out there. So that's what's happening with this 2. This is the 2 from before. Okay? Plus 4. Congratulations. Second point just earned. We have the velocity, we have the acceleration. You're so not done. Paul, what are your thoughts here?
Well, I was going to ask a question.
Yeah, what's up?
If you name them x prime of t and x double prime of t.
I'm totally okay with that. You could call this x prime of t, and you can call it x double prime of t. That's fine. Okay, we're not done though. Jose, what's up?
So first we combine, well, we multiply and add, and then we equal the equation is 0.
Okay, because the question is, what's the velocity when the acceleration is equal to 0? So I need to know, Jackie, you okay back there?
Yeah.
I see all the things. I'm not just shaped like Santa, I have his powers. Negative cosine 2t times 2 times 2 is negative 4 cosine 2t plus 4. And you've got to set that equal to 0. And you have to solve this. And Mr. Link went over all these skills with you last year. And I've gone over it this year too. You have to solve a trig equation. You have to solve a trig equation. Jackie, what are your thoughts?
I thought it said what it, like, to find the zeros of velocity and acceleration.
No, read it again. What is the velocity when the acceleration is equal to 0? So I'm setting the acceleration equal to 0, and I need to find out when this happens. Daisy?
I don't know, making a mistake here, but couldn't you cancel out the negative 4 with the positive 4?
I wouldn't want to cancel them out. You're not, this isn't an addition problem. You're not saying negative 4 plus 4. You're saying negative 4 times cosine of 2t plus 4. Paul? Okay, what if we subtract 4 on both sides? Is that legal?
Yes.
Okay, negative 4 cosine 2t is equal to negative 4. And then? Divide by negative 4. So where's the cosine of 2t equal to 1? Feel free to check out that unit circle. Where's the cosine equal to 1? At 0. So if the angle is equal to 0, then the cosine's equal to 1. So you might say that 2t is equal to 0. Which means that t is equal to 0. And bad news.
You're not done.
You get the wrong answer.
Oh,
Go back and read the problem.
Oh no.
oh,
There's
that's
something-
the
First.
So you gotta find the velocity.
Nope.
First, bro. So you have
It's first.
two zeros.
where t is greater than 0.
Number one.
One more time.
Where t is
Go
greater
way
than
back to the beginning of the problem. There's something we know about t.
Oh my god.
T has to be greater than 0. I can't use 0 because it's not greater than 0. It's equal to 0. I need to get greater than 0. Oh my god, how are we going to do that?
That's crazy.
I'm going to come back to my cosine expression, and I'm going to look at that unit circle, and I'm going to focus on the fact that it's a circle. I'm going to focus on the fact that on the unit circle, I can go all the way around as often as I want to. It is true that if the angle is 0, cosine of 0 is 1. But there's another angle that I could have used here.
2 pi.
Look at the unit circle.
How was that right?
Oh, if only Rebecca's arms were a little bit longer. No, it's just really short. The other angle is 2 pi. I heard pi from a couple of folks, but cosine of pi is -1, not +1.
See, that is 360. I was right.
And you said 360, but in here we only speak radians. Okay, so if 2t is equal to 2 pi, t has to be equal to pi. Congratulations. That gets you a point. The fact that you guys fell for t equals 0 is not a surprise. I was being really tricky. Hold on, Henry. Because we're still not done.
Oh yeah.
Still not done, Diego.
First equal to 0.
This is when the acceleration's equal to 0, but this isn't the question I'm trying to answer. Jackie, what's the question I'm trying to answer?
Go Jack and plug that t into the velocity.
I want the velocity when this happens. So what's the velocity?
Negative something.
The velocity is going to be negative sine of 2 times pi times 2 plus 4 times pi. And which section do we want to be on?
Free response.
If it's free response, you know what? You're done.
No, I don't want.
You don't need to know what the sine of 2 pi is on the free response. But let's think about multiple choice. What is the sine of 2 pi? Check out that unit circle if you have to. Sine of 2 pi.
180.
Sine of 2 pi.
Zero.
0. So what's the velocity?
4 pi.
The velocity is
4 pi.
4 pi. Nice. Not easy. Not easy. But nice. We got this, Gonzalo. All right, part B. At time t equals pi over 4, is the speed of the particle increasing or decreasing? Show the work that supports your answer. Oh. Have a strategy conversation about that one. Henry and Right, I'm asking you to solve the equation. Cosine of what angle equals 1? So where is the cosine equal to 1? That happens at 0. All right, friends, here we go. Okay, real quick. I heard from a couple of folks. I want to know if speed's increasing or decreasing. What you need to know? You need to know the velocity at pi over 4. And you need to know the acceleration at pi over 4. So I'm going to plug him in. I'm going to plug him in real quick. Negative sine of 2 times pi over 4 times 2 plus 4 times pi over 4. Your acceleration is negative cosine of 2 times pi over 4 times 2 times 2 plus 4. 2 times pi over 4 is pi over 2. Negative sine of pi over 2 is going to be negative 2 plus pi. 2 times pi over 4 is pi over 2. Cosine of pi over 2 is 0. And we're going to get 4. The velocity is negative 2 plus pi. Positive or negative?
Positive.
Positive. Because pi is 3 and some change. Velocity is positive. Acceleration is positive.
So the speed is increasing.
Speed is increasing at t equals pi over 4. Nice job, guys.
Yay.
Okay, tonight's homework, assignment number 43.
Si, senor.
Thanks, Karina.